Good to see you all. I like your uniform. That's awesome. Very stylish. And I'm Ting-Yuan too. This is my lab on the upper right, integrated MechanoBiosystems lab. So basically, what our lab is doing is we try to change the world. Okay, through engineering microphysiological systems for the complete preclinical pipeline. That's what we want to do. So I think, in essence, what does this mean? So basically, there are 4 pillars we have to achieve, and these 4 pillars basically meaning the 4 types of students we are seeking. It could be very, very engineering from one aspect to the other very end of the aspect that requires a lot of biology. All right, so this is the kind of talent we are looking at. So from the building perspective, to build stuff, it is more about building tools, right? So the tools we are building is microfabricated tools, devices, systems. Basically, we will use microfabrication techniques. So maybe this is foreign to you, but this is something we are doing, and we are very much welcoming students to come to our lab to learn. This is some of our prior works. Recently, we are more about implementing 3D printing, the high-end 3D printing to print devices of our interest. Modular devices basically is like Lego. We can connect devices together, doing screenings, one by one. So this is more about engineering, fabrication of devices. So in essence, if you want to fabricate devices, you kind of need to know what kind of tissue you want to simulate, what kind of microenvironment you want to simulate. So you want to create that device that is similar to that component per se. So the next thing is really about what is inside, right? With the device, the next thing is really about the model itself, which are cells. So we have it's very AI-like, right? Because I just throw in all my publication and ask LN to generate everything, from my publication. So this is kind of how he gave it to me. This is the type of works we do. We do a lot of 3D culture. So I'm not sure how many of you have done cells, but you kind of can imagine, 2D culture on plastics probably not very recapitulate the microenvironment in the body, which is very 3D. So we are primarily working on tumor model, and also we have done a few of the vessel on chip. So that is the blood vessels, and we have basically created a device that will allow us to study not just the cells alone, but also you want to study ECM. ECM is extracellular matrix. So that means in our body, it's not everything are composed of cells, right? There are also a lot of entering material. They are extracellular matrix. So that means we grab our skin down, we can see some skin cells for sure, but there are also a lot of collagen, right? A lot of hyaluronic acid, right? So those are extracellular matrix. So we have to consider all that, to create a device. So finally, we can use that device, to do some screening. So for instance, we have tested some of the nanoparticles. If you are interested in the developing, nanotechnology, nanoparticles, to conjugate drugs, that would be, a source of platform for testing the output. So eventually, I think another very engineering thing we are doing right now is we have the system, we have the device, but the only thing we are lacking now is the ability to do it to do it automatically. So in order to do this, we really need AI. So we have done a few of the primary AI-assisted image validation, and recognition, computer vision, to check our cells. So if any of this fields falls into your interest, you may think about it, and you may want to just drop me an email, and we can talk about it later. Thank you very much.